Okay, so this section, we're going to talk about two specific rules of finding derivatives, which are the product and the quotient rule. So, these actually enable us to find derivatives of functions where we're multiplying two functions together or when we're dividing two functions together. So there are some common misconceptions about these where some people say, well, can't I just use the shortcuts that we learned from section 1? And the answer to that obviously is no, or else we wouldn't have the product rule or the quotient rule. So let's talk about the product rule first. And then for these rules, the way I memorize them, I kind of talk myself through them. So that's what kind of helps me out. So if we're talking about the product rule, let's first talk about what a common mistake is that people make. And then I'll give you the rule to this. So a common mistake in finding the derivative of the product of two functions. So if, let's say, I'm multiplying these two functions, I want to find their derivative, and I'm sure you can guess by looking at this, you would guess is f prime times g prime. So in other words, some people say, well, if I'm trying to find the derivative of f times g, can't I just find the derivative of f and the derivative of g and multiply them? And the answer to that is no. And I could see why some people think this way, because just like in section 1, we talked about the derivative of the sum of two functions is the same thing as finding the derivative of each separately and then adding them up. And so I could give you a counterexample to this, actually one that you could even find without really having to apply the product rule. But think of it this way. Notice if, let's say, f of x equals to 2x and g of x equals to 4x cubed. So what we would say is, well, if f of x is 2x, then what do we have? F prime of x will be 2, and g prime of x will be 12x squared. And so if we were to follow this rule, what do we notice? And f prime times g prime would be the same thing as 2 times 12x squared, which is 24x squared. But f times g prime would be the same thing as what? 12 or 2x times 4x cubed prime. And so by following order of operations, 2x times 4x cubed gives me 8x to the fourth prime. And if I find the derivative of 8x to the fourth, see, this we could use what we talked about last section, which is 32x cubed. And clearly, you could see that these don't equal. So the claim I was making up here is false, because f times g prime gives us 32x to the fourth. However, f prime times g prime gives us 24x squared. Okay, so clearly they're not equal. So let me give you the product rule, and then we can do an example where we'll put this to use. Now remember, the product rule, the name pretty much tells us what it is. We'll use this rule whenever we're trying to find the derivative of the product of two functions or more. But this applies to the product of two functions. So if f and g are both differentiable, then the derivative with respect to x of f of x times g of x is equivalent to d dx f of x times g of x plus d dx g of x times f of x. So if you notice, I always kind of talk myself through these derivatives. That's the easiest way for me to remember. If you look at what's happening here, for a moment, this might look a little complicated, but all we're really saying is what? If I want to find the derivative of this product, what we do is we just say the derivative of the first function, which, see, what I'm doing here is I'm finding the derivative with respect to x of f of x, times the second function. And so when I find, I'm not finding the derivative of g here. Notice how all we're doing is finding the derivative of f times g, plus then we're saying the derivative of g, which is the second function, times f of x. So the way I translate this, and this is how I talk myself through these derivatives, and it's important to always talk yourself through the derivatives because it just keeps yourself from making mistakes. So the translation for me is like this. The derivative of the first times the second plus the derivative of the second times the first. So I highly recommend that anytime you guys find derivatives, you talk yourself through these derivatives because it's just going to make it easier for you to kind of follow what's going on, and it'll keep you from making small mistakes here and there. So of course, anytime you make a minor mistake, the whole thing is incorrect. So you want to make sure that you stay pretty consistent with this. So, and by the way, this applies to the product of 3 functions or 4 functions, as long as you follow this rule. So that if, let's say, we have 3 functions, it would be the derivative of the first times the other 2, plus the derivative of the second times the other 2, plus the derivative of the third times the other 2. So if you follow that rule, you notice that it's just the same thing over and over and over. Okay, so let's look at an example. And we want to differentiate the function y equals to e to the x times x squared plus 1. So you can go ahead and pause this and try to solve this yourself first, find the derivative first, and then play it just to hear out the solution to this. But if you look at this, we're taking the product of 2 functions. The first function is e to the x times x squared plus 1. So if I'm finding the derivative of this, y prime would be, now let's talk ourselves through this. The derivative of the first and the derivative of e to the x is just e to the x. So it'll be e to the x times x squared plus 1. Right? So it's the derivative of the first, which is this, times the second. So notice how I didn't find the derivative of the second. And then you say plus the derivative of the second, which the derivative of x squared plus 1 will just be 2x, and then the 1 zeroes out. So it'll be 2x times the derivative of the first, which is e to the x. Okay? And in this class, whenever you're asked to find derivatives and you're not asked to simplify completely, once you find the derivative, this is your solution. Don't go any further. Don't waste your time trying to simplify this, because if you were to simplify it, you may potentially make some mistakes, which then you'd lose points specifically on a test. But this is our derivative. Eventually, in certain cases, we'll be forced to simplify it, but if it says differentiate the function and you find a derivative, you're good to kind of stop here. Now, a comment I would make is, instead of distributing e to the x, if I wanted to simplify this, I may have I'd be better off factoring out the e to the x and then kind of trying to see if I could factor this any further. So just in case you're wondering, if you were to simplify this, the best way to simplify it is factor out an e to the x, and then you'd be left with what? X squared plus 1 plus 2x. And in this x squared plus 1 plus 2x factors further to x plus 1 squared. So this would be the derivative in simplified form. And you're better off just factoring rather than trying to multiply and combine like terms. Okay? So let's look at example 2. So if f of x equals to rad x times g of x, where g of 4 equals to 2, and g prime of 4 equals to 3, find f prime of 4. Okay, so this question's slightly different. If you look at this, what am I giving you? I'm defining a function f as the product of rad x and another function g of x. Now the problem here is I don't tell you what g of x is, okay? So if we read this question, what is it saying? Find f prime of 4. Now remember, when it says find f prime of 4, we first need to find the derivative of f and then plug in 4. So the first thing we need to find is f prime of x, okay? So if you notice this, right now this might look a little weird. It's like, wait a minute, we don't even have the function g. How could I even find f prime of 4? Well, don't worry about that because things are going to work out. If you look at it, I've given you some information here that will probably be to our benefit. Okay, so to find f prime of 4, we need to find f prime of x first. Okay, so if I were to grab f of x and write it as x to the 1/2 times g of x. And I just wrote the square root of x as x to the 1/2. I prefer, when I'm finding derivatives, to write roots as powers, as mentioned last section. So let's find the derivative of this. And notice how, once again, what am I doing? I'm multiplying this function to that function. So to find the derivative of this, I have to use the product rule. So f prime of x will be the derivative of the first, which is, use the power rule, 1/2 x to the power of negative 1/2 times the second plus the derivative of the second, which is g prime of x, times the first, which is x to the 1/2. Now, notice how one thing I want to point out is when I'm using the product rule, within the product rule, I use the power rule. And you may have certain instances where you're using multiple rules when you're finding a derivative, which is fine. But because notice how when you say the derivative of the first, you notice the only way I could find the derivative of x to the 1/2 is to use the power rule. So if you're wondering, do I have to stick to one rule? The answer is no. Notice how within the product rule, I have to use the power rule and so on. So that's fine. As long as you're using the appropriate rules, you have nothing to worry about. So now that I have f prime of x, now we need to find f prime of 4, which f prime of 4 would be 1/2 times 4 to the power of negative 1/2 times g of 4 plus g prime of 4 times 4 to the power of 1/2. Now, if you notice, g of 4 and g prime of 4, the good news is it was given earlier. So I could substitute those. And now we could actually find f prime of 4. So f prime of 4 equals 1/2 times, and 4 to the power of negative 1/2 is the same thing as what? 1 over 4 to the power of 1/2 times, and we said g of 4 was 2, plus g prime of 4 was 3 times 4 to the 1/2. And remember, 4 to the 1/2 is the same thing as square root of 4. So square root of 4 is just simply 2. So this becomes f prime of 4 equals to 1/2 times, this becomes a 2. So it'll be another 1/2 times 2 plus 3 times square root of 4, which is 2. So then what do I get here? 1/2 times 1/2 times 2, that's just 1/2, plus 3 times 2 is 6. And then combining these gives us 13 over 2. And there's our answer. Okay, so that takes care of the product rule. So now let's talk about the quotient rule, and then that'll pretty much wrap up this section. So the quotient rule, what does this say? So once again, I'll give you the rule, and then I'll kind of give you the translation that I use that helps me find the derivatives without making any mistakes here. So if f and g are differentiable, then we could say the derivative with respect to x of f of x divided by g of x. Once again, I can't find the derivatives of these separately and then find the quotient, because remember, for the product something went wrong, and same thing will go wrong with the quotient. So only for the sum and the difference we could find the derivative separately and then add them or subtract them. For the product or the quotient, we have these rules we need to follow. So this becomes d dx f of x times g of x minus d dx g of x times f of x all over g of x squared. So if you look at this, what are we saying here? This is the derivative of f of x, which the way I think of it is you have a quotient, you have a top and a bottom. So this is the derivative of the top, which is the derivative of f, times the bottom, minus the derivative of the bottom times the top, all over g of x squared, which is the bottom squared. So notice how the only derivatives I'm finding go up on top. This g of x squared is just saying whatever your quotient is, grab it and square it. So this is the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So the translation here is the derivative of the top times the bottom minus the derivative of the bottom times the top, and then all of this all over the bottom squared. So keep in mind that the best thing to do is when you're using the quotient rule is to kind of talk yourself through the derivatives, because that'll minimize you from having to make any mistakes. Okay, so to finish this section off, let's look at the third example, and then that'll pretty much do it. So if I say differentiate y equals to 3x cubed plus 4x squared plus 1 all over 2x squared plus 1, notice how this is a quotient, okay? And there's no way out of this. I have to use the quotient rule to find the derivative of this, okay? Now remember, there may be times where you could avoid using the quotient rule, but in this case, I can't avoid it. However, like for example, what I'm saying is, if I ask you to find the derivative of, and I'll write it off to the side, you don't need to put this in your notes, is this. If I said find the derivative of x cubed divided by x squared, for example, you could use the quotient rule, but you're better off saying, wait a minute, x cubed and x squared, I could simplify this to x, and I could find the derivative of x, which would be the same thing as that. So you could avoid using the quotient rule for something like this. But for this right here, I can't avoid the quotient rule. So to find the derivative of this, let's talk through this. It's what? The derivative of the top, which would be 9x squared plus 8x times the bottom, which is just 2x squared plus 1, minus the derivative of the bottom, which ends up just being 4x times the top, which is 3x cubed plus 4x squared plus 1, all over the bottom squared. Okay, and so there's my derivative. Now, once again, if you were asked to simplify this, I would probably try to factor things as opposed to multiplying things through. But in this case, if you look at this, there's really nothing you could factor. You'd have to multiply and combine like terms. But since this just says find a derivative, and I found a derivative, I'm good enough to stop there. Now, remember, there will be instances where we'll be forced to kind of simplify this. But if you're ever asked just to find a derivative, find the derivative and move on, especially on the AP exam. If they say find a derivative of this, you don't need to go any further than just showing the derivative. Now, whether it's simplified or not, they don't care about it. But we'll see that later on in this chapter and in the later chapters to come. When we find a derivative, we'll need to simplify it to some extent so we get some information about y and y prime itself. Okay, so this basically wraps up the section. Remember, we mainly talked about finding the derivatives of when we're multiplying two functions together or when we're dividing two functions from each other. The one thing you just need to keep in mind is to avoid from having to make mistakes, always talk yourself through the derivatives. I mean, it's helpful to me, and it kind of helps minimize me making mistakes when I'm finding derivatives of especially when they're long, complicated functions. Okay, so that basically takes care of this section.